Right now, as you're reading this sentence, the ground beneath you is moving. Not shaking, not cracking, just drifting. A few centimeters a year, slower than your fingernails grow. And yet, this invisible, silent motion is the exact same force that has flattened cities in less than 60 seconds. Here's the unsettling part. Scientists can track hurricanes days before they hit. They can predict volcanic eruptions weeks in advance. But an earthquake? It can happen right now, while you're sitting there, and nobody on Earth would have known 30 seconds ago. Not one person, not one machine, not one warning. Why? Why, with satellites orbiting our planet and supercomputers modeling the weather down to the hour, can we not predict the one disaster that kills more people, on average, than almost any other natural event? To understand that, you need to understand something most people never think about. The ground you're standing on is not solid. I know it feels solid, but you are standing on a raft, a massive, cracked, floating raft of rock, drifting on a sea of molten material so hot it behaves like thick, slow-moving liquid. This raft is broken into pieces. Scientists call them tectonic plates. And here's the thing that should genuinely disturb you. These plates are enormous. The one under North America stretches from California all the way to Iceland. And they are all moving, constantly, grinding against each other in the dark, deep beneath your feet, every single second of every single day. Now here's where it gets interesting. Most of the time, these plates don't slide smoothly. They get stuck. Friction locks them together, like two pieces of sandpaper jammed against each other. But the forces pushing them keep building and building and building. Think of it like this. Imagine slowly bending a wooden ruler with your hands. At first, nothing happens. It just bends. But you keep pushing and pushing until suddenly, without warning, it snaps. That snap isn't slow. It's instant, violent. All that stored energy releases in a fraction of a second. That is exactly what happens underground. Except instead of a ruler, it's rock. And instead of your hands, it's the unimaginable weight of an entire continent. When that stuck section finally breaks free, the energy that was building for years, sometimes centuries, releases all at once. And that release sends shockwaves racing through solid rock at speeds over 11,000 miles per hour. 11,000 miles per hour. Faster than a bullet. That's how fast the ground can start shaking beneath a city that seconds earlier seemed perfectly calm. But here's the question that keeps seismologists up at night. If we know plates are stuck, and we know pressure is building, why can't we just calculate exactly when they'll snap? Because rock doesn't behave like a ruler. It doesn't break at a predictable point. Some sections might hold enormous pressure for 300 years. Others might snap after 50. The exact moment depends on microscopic cracks, tiny mineral structures, and pressure points buried miles underground that no instrument can fully see. It's like trying to predict the exact second a stressed piece of glass will shatter. You know it's under pressure. You just don't know which molecule gives way first.
This is why earthquake scientists don't talk about if, they talk about when. Entire regions are known to be overdue for a major quake, sometimes by decades. And people live their entire lives on top of that ticking clock, going to work, raising kids, completely unaware. Now here's something that might change how you see cities forever. Some of the most dangerous fault lines on Earth run directly beneath major cities. Not remote areas, not deserts, cities packed with millions of people, going about ordinary days, while deep underground, two enormous slabs of rock are locked in a silent, decades-long struggle. And when that struggle ends, it doesn't ease into motion like a slow wave. It detonates. In under a minute, an ancient building can turn to rubble. A bridge that stood for 80 years can collapse into a river. This isn't fear-mongering. It's physics. It's already happened in city after city throughout history. But here's where the story shifts, because humans, understanding this threat, didn't just accept it. They fought back with something remarkable. In certain earthquake zones, engineers now build skyscrapers on top of giant rubber and steel cylinders called base isolators. When the ground shakes violently, the building barely moves at all,
because it's floating, essentially, on a cushion designed to absorb the shockwave.
Picture a boxer rolling with a punch, instead of standing rigid and taking the full hit.
That's what these buildings do to earthquakes.
And it gets stranger. Some countries have developed early warning systems that can give people a few precious seconds of alert. Not minutes, seconds. But those seconds are enough to stop a train, shut off a gas line, or get a child under a desk.
A few seconds, born from decades of science, standing between order and disaster.
Here's a thought experiment. Imagine you had exactly 10 seconds of warning before every major decision in your life. 10 seconds to brace, prepare, adjust. Wouldn't that change how you move through the world?
For millions of people living on fault lines, that's not a hypothetical. That's their reality. And yet, despite all this technology, all this brilliance, we still don't know the day. We still don't know the hour. The Earth keeps it secret. Which brings us to something almost poetic. For all of human history, we have built cities, empires, entire civilizations, on top of forces we still don't fully understand. We've mapped the ocean floor, we've sent machines to Mars, but the ground directly beneath our own feet remains one of the last true mysteries on this planet. Maybe that's the real story here. Not the destruction, not the danger, but the reminder that certainty is often an illusion. The stillness you feel right now, sitting there, reading this, isn't guaranteed. It's borrowed. Quietly, patiently, the Earth is always moving, always building towards something, on a timeline that answers to no one. And somewhere, right now, deep beneath a city full of people who think today is just an ordinary day, two ancient slabs of rock are pressing against each other in the dark, waiting.